So hello to all my young friends who are studying in intermediate and they are watching this video. Welcome to the lectures of GTK Academy. In our last video, we had discussed Newton's laws of motion. Today we are going to discuss another topic and the name of the topic is friction. Friction is again a very important as well as interesting topic. Lot of questions are asked from this topic in competitive exams, which makes it even more important. And as indicated in my previous videos, I am going to discuss each and every concept in detail in this video, and I am going to cover the whole topic in one video. So I request you to pay full attention. So without wasting much time, let's start the topic, that is friction. Now we all know that Newton's first law, which we had discussed in our previous video. I hope that you would have seen it. If you have not seen it, please do see that and the videos prior to that. Newton's first law says that every body continues to be in its state of rest or uniform motion unless there is an external force. That means if the body is at rest, it will be at rest, and if it is in uniform motion, it will continue in that state until and unless there is some force which opposes motion or tries to change this state of rest. However, if we initiate a sliding or rolling motion and leave it, we see that the motion stops after some time. Suppose you take a block here on a horizontal surface and you apply some force and give it a movement, give it a motion, initiate a motion. So now it is moving, but after some time it will stop. Or if you have a disc, a wheel or a cylinder and give it rotational motion like this so that it moves in this direction, you will observe that it will stop after some time. But Newton's laws says that it will continue with that. Then what is the thing which is making it stop? What makes it stop? Even if we neglect air pressure, some people may think it is stopping because of air pressure, but generally air pressure is negligible in most of the cases. So if we neglect the air pressure, then what is the thing which is stopping the motion? The answer is friction. Now friction is a force that resists the sliding or rolling of a solid object over another. I hope I am very clear with this and you are able to understand this basic definition of friction. Friction is an opposing force which comes into play. Please note, this is very important. When one body actually moves or tries to move over surface of other. If it doesn't move or if it doesn't try to move, friction will not come into picture. There will be no friction. Anyway, we'll discuss that as we proceed. Now consider a body placed on a horizontal surface. This is a body, this is a block which is placed on a horizontal surface. Now we apply a little force, a small force, the body does not move. I have indicated that force by a small arrow. Now we slowly increase the force. Slowly we increase the force. I am increasing the size of the arrow, which indicates that I am increasing the force. The body starts moving when the force reaches some threshold value. When the force reaches some value, the body starts moving. Say, for example, I have initially put 0.5 Newton. The body does not move. I increase it to 1, 2, 3, 4. Then say 5.5, the body starts moving. So till 5.5, body does not move. And when I increase it further, then only the motion starts. So that means there is some force which is opposing this motion, some force which opposes this motion, because when I had put a little force, the body didn't move. I increased it, and when the force reached a threshold value, then only this body starts moving. So there is a force which opposes this motion. This force is called friction. I hope you have understood this. Now, roughness of a surface is responsible for friction. So what do I mean by that? Suppose I take some surface like this. Now, this surface I am just highlighting with red. This surface probably may appear very smooth to me if I look at it from naked eye. But if you put this under microscope, you will find that it is not that smooth as it appears to be. For example, it may appear like something like this, some kind of irregular shapes. Although this thing appears smooth to our naked eye. Now, when this surface tries to move over another surface which again has that kind of, you know, now we have two surfaces, one shown by black color and other by red color. There is going to be opposition to this movement because of this irregular shape. So this is called roughness. So roughness of a surface is responsible for friction. Even a very smooth surface, which you may feel it's a very smooth surface, when you see through a high resolving microscope, it will look like this. Now you can see how the surfaces which appear very smooth, how irregular they are in shape. So this is called basically roughness, and what I mean by roughness here. So this roughness is responsible for friction. Now let us discuss the theories of friction. Basically, I am going to discuss two theories here: classical or conventional theory, which was prevalent for a long time. As per classical theory, friction of a surface depends upon its roughness. Like this, what I had discussed just now. This is one surface and this is another surface. The irregularities which are present on the surface, they form interlock. Suppose you try to move this surface over this surface, say this is surface A and B. If you try to move A over B, these irregularities will form interlocks. And an external force is required to break this interlocks. That force is a measure of friction. The more external force is required, the more is the friction between these surfaces in contact. Now, what are the drawbacks of this theory? I think the theory is clear. The theory says roughness is responsible for friction, and because of this roughness, interlocks are formed and you require some force to break these interlocks. Now, what are the drawbacks? Apparently, anybody who is studying friction for the first time may think that this theory is absolutely correct. It's very logical, but there are certain drawbacks. Now, as per this theory, the larger the area of contact between the surfaces, the larger will be the force of friction. It is evident because if you have larger area of contact, there will be larger interlocks and larger force is going to be required. However, experiments have shown that force of friction is independent of area of contact. That is what experiments have shown. Again, as per this theory, if the surface in contact are extra smooth, then friction should be very less, because if they are extra smooth, there will not be interlocks. But again, the experiments have shown that the force of friction increases instead of decreasing. When you make it more smooth, extra smooth, the force of friction increases instead of decreasing. So these are the two drawbacks. Probably you may have some doubts on this. I am going to clarify that when we see the modern theory. Now, what is modern theory? Modern theory says, or as per this theory, the cause of friction between two surfaces in contact is the presence of strong atomic or molecular forces at the point of contact. This theory says that at the point of contact of two surfaces, there are strong atomic or molecular forces. And again, a very important thing, that actual area of contact is much smaller than the apparent area of contact, and the ratio is of the order of 10 raised to the power 4. That means if apparent area of contact is A, say A dash or something like that, then this is your apparent area of contact, and actual area of contact is of the order of A dash divided by somewhat like this. So what do we mean by this? Let me explain. This is a block and I keep a conical solid over this. Now you can see this is the contact surface where these two surfaces are in contact, surface of cone as well as this cuboid. Now this is your apparent area of contact. means what we see from our eye and we think that this is the area of contact. But the actual area of contact are these. I've just drawn this surface, bigger one here. These are very small portion. This is the actual contact, not this whole area as I have shown here. Hope you are able to understand. Now, for these point of contacts, the molecules come very close and they exert strong adhesive force on each other. As a result, adhesive pressure, which is force upon area, becomes very large. Now, what do I mean by adhesive pressure? Now, suppose for this cone will have a weight mg. So now the force will act on this surface. So pressure will be mg upon this area. But this area is apparent, it's not the actual point of contact, actual contact surface. Actual surface will be mg upon a dash, where a dash is very less than a. That means when you decrease the area, the pressure will increase. So adhesive pressure becomes very large. Because of this adhesive pressure, cold welds are formed. I think some of you may be aware what is a cold weld. See, cold weld, we join two metals generally by hot welding. That is, we melt the metals and they form a liquid. Their molecules come very close to each other, and then when you uh, decrease the temperature, it solidifies and molecules are very close to each other, and there is a very strong adhesive force. But in case of cold welding, instead of melting the metals, you put lot of pressure and bring the metals very close so that their molecules come very close to each other, extremely close to each other. You have to put a lot of pressure for that, and then strong bonds are formed, which is called cold welding. So because of this adhesive pressure, which is very large, cold welds are formed. I hope you understood this. Now, if you see these two surfaces, says this is a surface A and this is a surface B, apparently this whole area is the contact area, which generally we see through our naked eyes, but actual contact are these. You can see only contact is at these points. So the actual contact is shown in purple color. These are the actual area, actual points of contact or actual area of contact. Now, as per this theory, the force of friction is independent of area of contact, as per this theory. Why? The reason is that with increase in area, the adhesive force increases in the same ratio such that F upon A remains constant. Now, adhesive pressure is F upon actual area of contact. A actual. When you increase this area, F also increases, but both these things increase in such a manner that F upon A remains constant. So, friction is independent of area of contact. The other thing, as per this theory, if surfaces in contact are made smooth, force of friction increases. What experiments have shown to us? Why it happens? The reason is when you make it more smooth, the distance between molecules decreases, resulting in increase of adhesive pressure. And when adhesive pressure increases, cold welds are formed, which again increase friction. So I hope you are clear with both these theories, classical as well as modern. Now let us analyze the forces on a block of mass m resting on a horizontal surface. For example, this is a block which is resting on this surface. This is a surface. There will be a weight of the block mg acting downwards, and what happens? This block will exert a force on the ground because of its weight, say W. As per Newton's third law, for every action there is an equal and opposite reaction. So ground will also exert a force which will be equal to W in the form of reaction R. In the same line as mg, I have drawn it here just. So W will be equal to R. So ground will exert a reaction R. So there are two forces acting on the block. One is mg, its weight, and the other is reaction. And R is equal to mg. That is the reason block is in equilibrium. Now what happens? If you apply some force here, as I have said earlier, immediately an opposing force comes. Otherwise it should move. If you apply a very little force here, you will see that in many of the cases it will not move. So there is a force which opposes this F, and this F is equal to this force. Then only it will not move. Otherwise, if this F is greater than small f, it will move. So that means this F is the force of friction. It opposes the motion. First, please understand this is the basic definition of friction. It is parallel to the surfaces in contact. See, this is one surface and this is the other surface of the block. This friction is parallel to the surface in contact and it is self-adjusting. Now, what do I mean by self-adjusting? By self-adjusting, I mean that if F is increased, capital F, this is small f will increase. If it is decreased, small f is also decrease. Whatever is the requirement, this small f, this force of friction, adjusts according to the requirement. Let's see from some examples. If we apply a force on this block, there is a force of friction. So whatever is the force here, the same is the force of friction generated. I have shown by two equal arrows. Now if you increase this capital F, small f also increases. If you go on increasing it, this will increase. But if you decrease it, then this will also decrease like this. That is what I mean by self-adjusting. I hope you have understood this. But the important thing is this is self-adjusting till the motion starts. Now what do I mean by this? Till the motion starts. That means if you increase it, this will increase till it reaches a particular value after which the motion starts. This is called, particular value is called Fs, which we will call limiting friction, or that is the maximum value of friction. We are going to discuss in the coming slide in detail. So, force of friction is self-adjusting till the motion starts. Now, what are the types of friction? Static friction, when there is no motion. Suppose there is a block and it's not moving. We are applying some force, but there is a force which is opposing that. That means there is a force of friction in this direction. So when there is no motion, it is called static friction. Then dynamic friction. In dynamic friction again, we have sliding friction and we have rolling friction. What is sliding friction? Suppose there is a block which is sliding. That means there is a sliding motion. You are putting force here in this direction and this block is sliding in this direction. And there is a force of friction which is opposing the sliding motion also. That is why if you make this force zero, it will stop after some time because of this friction. So this is called sliding friction. And what do we mean by rolling friction? Suppose there is a cylinder and it is rolling. That means we are applying some force and there is a rolling motion involved here. It is rolling in this direction. And when it is rolling, again there is an opposing force. So if you stop applying the force, it stops after some times. You must have seen, if you just apply some force on a roller, it will roll till you apply the force. And if you leave it, after some time it will stop. So there also there is a friction involved. So I hope you are clear with all these three kinds of friction which we are going to discuss here. Primarily two kinds, static as well as dynamic, and dynamic is again further divided in sliding as well as rolling. Now let's discuss static friction. Now I have already discussed, if there is a block placed on a horizontal surface and we apply a force which is not sufficient to move a block, these are the forces which are acting on this block. One, reaction, one, its weight, our force, and the force of friction. So we'll just draw them here. mg1, R, reaction, the force which we are applying, and friction, shown by small f in red color. Now what we do, we'll take the resultant of this R and its small f. Say this is R dash. So now we'll knock off these two because we have already taken the resultant. Now this finally becomes three forces, R dash, F and mg. Now we have already discussed this in our topic scalars and vectors, that if any body is in equilibrium and three forces are acting on that, they all form a closed triangle. So here if the block is in equilibrium with F, R dash and mg, then these forces, all three forces should form a closed triangle. So this is your F. Now shift mg here, mg and R dash. So all these forces will form the closed triangle taken in the sides of a triangle taken in order. Suppose this is A, B, C. Now F vector is equal to AB, mg is equal to BC, R dash is equal to CA. That is what we mean by taken in order. AB, then BC, then CA, not AC. So these all will represent a closed triangle. Now we know that if we increase this force of friction will also increase. Now if we increase F, this small f will increase and hence resultant will also increase, and it will be more tilted on the left side. If you have angle theta 1 here and this is theta 2, so theta 1 is less than theta 2. That means R dash is tilting towards left. If you further increase, R dash will also increase and it will be tilted more towards left. So this is theta 3. So theta 3 again is greater than theta 2 until you reach the maximum value, which we said this is Fs. So again, if this is theta 4, in fact we call it theta s. So instead of theta 4, I'll write theta s. So theta s. Now this maximum value of force of static friction, this comes into play when body just begins to slide. That means if you further increase this force F, now this is the limit of the friction. Friction cannot increase more than Fs. This is the maximum value. Then what happens? The body starts sliding, and this is called limiting friction force and it is denoted by Fs. Now we have already said that this angle is theta s and Fs is the limiting friction force and theta s is called angle of friction. Now Fs, maximum force of friction, is proportional to R. That means this reaction. Again, reaction is proportional to mg, and in this case reaction is equal to mg because the surface is horizontal. Otherwise, the value of reaction may be different. In fact, that we'll discuss once we proceed on this topic. So, maximum friction force is proportional to the reaction. Now, if we have to remove this sign of proportionality, what we do? We multiply by a constant. So, Fs is equal to some constant into R, and we call the constant mu s. Now, this mu s is the constant of proportionality, and it is called coefficient of static friction. Coefficient of static friction. So, mu s is equal to Fs upon R. Now, what is Fs upon R? Now, this side is your Fs. So, this side is also Fs. And this side is your R. So, Fs upon R will be equal to tan theta s. So, we can write mu s is equal to tan theta s. I hope you have understood this. So, we have a very important relation that Fs is equal to mu s into R. But the point which is to be noted here, that this relation holds only when friction has a limiting value, that is Fs. We can write Fs is equal to mu s into R, but not F is equal to mu s into R. This is not equal. No. Because the friction is less than mu s into R. The maximum friction is equal to mu s into R. You can see that. Now this is your F. Here F is, increased if you increase the force. But when F reaches the maximum, certain value, and friction reaches the maximum value, in this case, this is equal to mu s into R. Otherwise, this F is less than mu s into R. This is also less than mu s into R. Now, animation, an interesting animation, depicts the increase of friction till the limiting value. Just to make it interesting, say you have a block placed on a horizontal surface. Two forces are acting, mg and R, and we have not applied any force, so there is no friction. Friction only will come into play when the body moves or tries to move. Now, if we apply a force slow and increase it slowly, so friction will reach its maximum value Fs. If we apply force on this side, so friction acts, force is in this direction, friction is acting in this direction. If we, instead of this side, we apply the force on this side, what happens? Very simple. The friction acts in this direction and it reaches Fs. Now, what is sliding friction? And I hope you are clear with the static friction. Now, sliding friction when the motion starts, the frictional force between the surfaces decreases. That means when you start the motion, you apply